Hello there, ROS developers, and welcome to this live class number 112, where we are going to be reviewing a little bit of C++ for robotics. In this case, we're going to be talking about arrays and pointers. So, let's start. Alright, so hello there everybody, welcome all of the ROS developers that we have gathered today here for this live class. And as I have just said, today we are going to be doing live class number 112, and we are going to be practicing a little bit with some basics of C++, always focused on robotics like we always do. So yeah, let's go for it. Welcome everybody. Let me know if everything is fine, image is fine, sound is fine, so that we can keep going. I can see many people here in the chat today. Hello, Panduru, Tanchiu, Marvin, Garibay, Andrew, Spirit, Miyagi, Miguel, Rohit, Abubak, Misho, everything, all is fine, all good. Okay, excellent. Then let's go for it. So let me know here in the chat if you are new to live classes. I see some names here that might sound new to me. So let me know here in the chat if you are new to live classes or if you already know how they work and the typical procedure. In any case, I'm going to explain it. So here in live classes, what we do is to try to teach some concept by practicing. We always focus it on practicing. So now, before we start, I'm going to share with you a ROSject, what we call a ROSject, which is basically a ROS project, a full ROS project, which can be shared with a simple click, so that you can get it wherever you are. It doesn't matter. So we are, I am new to live class, says Niranjan, welcome for all. I am new. Okay, so many new people, great. Then let's, better than talking, I think it's better always to show it. So let's go for it. I'm going to switch right now to my computer screen. There we go. Then here we are going to be working on the construct application, which is our application. So first thing, I will need you to log in here. In case you already have an account, just log in. In case you don't have an account, just create it. It's free and it's going to take you just a few seconds, so just create it. Then what I'm going to do right now is to get today's project, because I don't have it actually here, I think. No, the last one is last week's live class, 111. So let me get the project for today's live class, which I have here. And I'm going to, in this case, I'm going to paste it directly here in the URL bar. And this is going to automatically copy into my workspace the project for today's live class. Here you are going to see it. Here I have it. So ROS Developers Live Class number 112. Basic C++ for robotics, arrays, and pointers. Great, so what I'm going to do right now is to share this same project with you. So let me click here in the share button. I'm going to copy the link from here, and I'm going to paste it here into the chat. Let me find it. There we go. I'm going to paste it here into the chat 3 times. All right. Then now all you have to do is to first, of course, log in into the construct application. And then once you are logged in, you can click directly on this link. You can copy and paste it as I have done. And by doing this, what you are going to do is to automatically get this project, which is the one that we are going to be working with today. So here, as you can see, in the left menu, you can go to the different sections. Here, where I am is in the ROS Development Studio in my ROSjects. Yes, here is where you are going to get this ROSject. So in my case, you can see more ROSjects here because I have been working on them. In your case, if you are new to the application, you are going to probably have this empty, or it's going to be different. In any case, once you copy this ROSject, you are going to be able to see it here into the My ROSjects section. Yes? Then here you can look for public ROSjects. These are ROSjects that other people has been developing, doing, whatever. You can see different public ROSjects. You can check them if you want. For instance, here you can see our courses. We have many different courses. You can filter them by categories, whatever. Here we have the robotics theory ones or basic ROS. Today, for instance, we are going to be focusing on this one, C++ for robotics, which, by the way, it's a free course. So you can access it by free. There are other ones that you need to be subscribed in order to access to them. But this one, the one about C++ for robotics, it's free. Same as Python, for instance. So you can open it and start doing it. So yeah, in case you want to do this after the live class, feel free to do it. And yeah, in case you want to check any other course, just check it. So one thing I would like to comment before starting today's live class is that if you are already a subscriber of our page, you probably already know that we have migrated some of the courses to ROS Noetic already. And for today's live class, also, we are going to be working with ROS Noetic. So I have created today's ROSject in ROS Noetic. So the last live classes were about ROS2. We were working with ROS2 Foxy in this case. And for today, we are going to go back to normal ROS, let's call it like this, or ROS1. And we are going to be working with ROS Noetic. Then, okay, so with the introductions being made, let's go for it. Then in order to open this ROSject, all we have to do is to click here in the Run button. So let me do it right now. And this is going to start opening and loading the ROSject. So, okay. Here I'm getting some connection error. I don't know why. Let's see if this gets fixed. Let me check here. Yeah, so everything seems to be working fine. Let me see if I can move around here. Okay, so I don't know why I'm getting this no internet connection detected thing, to be honest. Let me see if let me try to access to a different, yeah, so apparently I have access to internet here, so I don't know. Okay, let's try to open it in. Yeah, but so I can see in the chat, I get the same issue on the side. Florencia is saying, same problem here. I get the same internet connection error. Okay, so apparently it's something general, not from. Okay, now it's gone. Now it's gone. Yeah. Okay, so this seems to be working. Now, okay, let's try now. Yeah, okay, so it's gone. Yeah, I don't know what that was. I don't know, maybe it will fix it. Same with me. Okay, yeah. Well, in my case, it has just gone by itself. So yeah, maybe it was just a temporal issue with the platform, some service that went down. But yeah, it should be back to normal. So let's just keep going. Then click on your projects, click on the run button and start opening just as I have done. Then as you can see, this is going to automatically open the project page and it's going to start loading all the services. As you can see here, this should take some seconds, not too much. So let's just wait a couple of minutes here so that you have time to have your projects open it and everything. Mine fixed itself, says Florencia. Also Andrew, great. Hello Engineering Nations, hello there. Say sorry, a bit late. Don't worry. Okay, so let's see if this loads properly. Let me open here a new window. Okay. I don't know if mine has been opened correctly. Have your projects been opened? They're in the chat. Hi. This is taking too long to load, to be honest. It shouldn't be that slow. So I don't know. Have your projects been opened properly? Yes, open it. Same as you. Yeah, it is strange. I think I'm going to close and open it again. So let me do this. Let me come back here to my home, my projects, and I'm going to open it again because I don't know if it is strange that it takes that much. So let me try it again. In process opening, yes, but after a few tries, desktop has loaded. Yes, says Colby Borchetta. Okay. Mine is taking too long. This should be super fast to load. So I don't really know. Okay, I'm going to just wait. I'm going to just wait a bit more. Maybe it's just that it's loading slow. So I'm going to do it like this. I'm going to just wait a bit more. Okay. Buru says, why the kernel of Jupyter Notebook is restricted? I think Noetic by default should come with Python 3 support. Yes, that's right, Sri Bastava, Buru. Yes, so ROS Noetic comes with Python 3 support. So this is like this. In any case, our Jupyter Notebook, maybe it has still the 2 kernel, but we are not going to execute anything from the Jupyter Notebook directly as a Python script. So it's not going to affect. In any case, in the following days, we are working also on updating the Jupyter Notebook version. So don't worry about that. But yes, as you point out, ROS Noetic already comes with Python 3 support. Maybe you can provide a wired connection, not Wi-Fi. Yes, I'm actually on a wired connection, Spirit. So here, where I'm doing the live class, I'm wired. I'm not using Wi-Fi because of this, basically, because I don't trust Wi-Fi, so I prefer to be wired. But yeah, I don't know. Maybe I'm having some kind of issue. I don't know. Should we open ROS navigation in 5 days? Noetic? No, Florencia. No. No, you should open the ROSject, this one. The ROSject I have shared there in the chat. This one, ROS Developers Live Class number 112, Basic C++ for Robotics, Arrays and Pointers. This one, you should open it. Clicking here in the Run button, you should open it. I'm asking here to my colleagues to see if they can tell me if there is some kind of issue. All right, there we go. So yeah, everybody should open this one, which is what I'm, okay, it seems like services are starting to open. So apparently it's just a slowness issue. So it's just opening everything slower than usual. Okay, so I'm just going to just wait a bit more. So let me keep reading here the chat. Nothing happens when I click on Get ROSject. Nothing happens when I click on Get ROSject. What do you mean, Ulrich? Where are you clicking on Get ROSject? So you should, guys, click here in the button, in the link I have shared here in the chat. I have shared this ROSject link. Let me, in fact, let me share it a couple of times more. So let me share it a couple of extra times, just in case someone is late. So you should, guys, click on this link or copy paste it directly here into the URL. It also works. And then this is going to basically copy this ROSject into your ROSject section. You can see here my ROSject section. So if you come here, you are going to see you have this ROSject here. Yes, but for this you need to click on the link or copy paste the link I have shared there in the chat into the URL bar. So this is going to automatically copy this ROSject into your space. I am able to run the ROSject, says Niranjan. Okay, great. Yeah, in my case, it seems like it has already loaded, which is great. So here I have it loaded. Then what I'm going to do now is to click here on the Jupyter Notebook. So this is going to open the notebook. As you can see here, it's where we are going to be following the instructions and everything. We have here the ROS Developers Live class number 112. Yes? So all of you should do the same. You should, once your ROSject is loaded, you should click here on the Jupyter Notebook in order to have this notebook opened. So let me please know if you are on this same point so that we can keep going all together. Colby Borchetta saying copy and paste did not work. Clicking the link in the chat worked for me. Okay, I don't know. I did it by copy and pasting the link, in fact, here. So I don't know why it didn't work in your case, Colby. In any case, you can do both. So if for any reason it's not working the copy paste, just click directly on the link. It works, thank you. Florencia says, oh, that's great. Thank you for the link. I was trying to access the project through the live classes menu from home. No, Florencia. From that live classes menu, you can access past live classes. If you're a subscriber, you have access to all the past live classes we have been doing. So this live class is number 112. But for the new ones, so for the one we are doing now, we are providing the link to the ROSject live, so that the people who is here in the live stream can access it and be working with me. got it, I'm ready. It's slow, yeah, it's a little bit slow, just be patient. Yeah, I have opened the Jupyter notebook, open it, done. Okay, excellent, excellent. Then we are all in the same page. So yeah, as I have said, today we are going to be doing a basic C++ for robotics live class, specialized in arrays and pointers, which are two tools very used in C++, and especially when developing in robotics, they are also very useful, arrays and pointers. So we are going to be checking how to work with these C++ specific tools. Then, yeah, so here we have a couple of requirements in order to better follow this live class, which are the Linux course and C++ basics. I have shown before how to go to the courses, so you can check them. Both are completely free. Then, yeah, so first thing we are going to do is to load the simulation. We are going to be working with a gazebo simulation today. So here, in how to launch the simulation, you're going to find the instructions to launch the simulation. So let's start following them. We can do them all together. So first thing is to open a shell. So I'm going to do right now here. In the bottom menu, I can click here and this is going to open a shell. Then the first thing I need to do is to source the proper ROS version. In this case, we are going to be working with ROS noetic. So I'm going to source ROS noetic. Next, I'm going to be sourcing the simulation workspace. And what is this workspace? Where if I click here in the code editor button, here in the bottom menu, if I click here, this is going to open my IDE, my code editor, where I'm going to be able to visualize everything graphically. I don't know why it is. There we go. Okay. So here I can have access to all the workspaces that I have here in this project. And one of them, as we can see, it's this one, simulation workspace. So inside here is where I have placed all the packages related to the simulation. Yes. Then this is why I need to also source this workspace. So in this case, I'm going to just copy and paste directly this command from the notebook to the shell. And finally, we have the ROS launch command, ROS launch, ROSbot gazebo CPP wall. So this is the command that is going to actually launch the simulation. So I'm going to as well copy it here directly from the notebook and paste it into the shell. And this is going to start loading my simulation. So now, in order to visualize it, all I need to do is to click here in the gazebo icon. I can click here in the gazebo button, and this is going to open my gazebo window, and if everything is right, I should see here the simulation loaded. So let's wait a few seconds until the connections are done. Right. There it is. Okay, great. So here I have it. Here I have the simulation. As you can see, we have here a ROSbot 2.0 robot. Here, very, very small. You can zoom it. This is just a regular gazebo, so you can zoom it in order to check it better. You can see it's a 4-wheeled robot. You can see here it has a Kinect, a 3D camera mounted on it, also a laser, which we are going to be working on. Very interesting. And in the environment, we have here a wall. It's basically in front of a wall, the robot. So yeah, so this is the initial setup. We have already launched the simulation. So now what I'm going to do is to minimize this shell, because here is where I'm going to have the simulation running, so I don't want to touch anything here. I don't want to close it by accident or anything. So what I'm going to do is to minimize it and leave it there. And then here, I'm going to go back and click on the plus button, and this is going to open a new shell for me. So this is the one I'm going to be working on. And this way, I'm not going to be touching the one which has the simulation running. All right. Then, yeah, okay. So yeah, this is the first, the initial setup. I want all of you to be on the same page as I am. So here you have the instructions in case you miss at any point. So yes, now we are ready to start. Then please confirm in the chat that all of you are in this point. So you have opened the project, you have the Jupyter notebook here opened as well, and the gazebo simulation here loaded. So this way we can start with the class and keep advancing all together. So for the ones who are new in live classes, I always repeat this a lot because so I don't want you to be there just listening to what I'm saying and watching what I'm doing here, but I want you to be practicing with me. So this is why I'm sharing this project with you, so that you can have it and open it, because I want you to practice with me. So at the same time as I'm going to be here doing some explanations and doing some exercises and whatever, you can be doing it with me. So you can listen to me, of course, but you can practice at the same time as I practice. So this is why I want all of you to be on the same page, so that you just don't stay there listening and watching to me, but that you also practice with me. This is what I would like to. Then okay, ready, don't sir. What's the problem? Okay, I can see my colleague Ricardo here, which is giving some support. Everything is loaded, good to go. The simulation still didn't open up. Okay, maybe it's going to take some seconds. Mr. Ahid. Yes, ready. How can I delete spheres and shapes I accidentally added to this simulation? Asks Florencia. Okay, that's pretty simple. So in case you accidentally add, like I have just done here, something to the simulation, you can right click on the object. Oh no, actually, I think it's disabled. The right click. We have it disabled, maybe. No, yes. You can control right click here. No, actually, yeah. And then here click on the delete button and it's going to delete it. Okay? In any case, you can leave it there. Don't worry. It's not going to affect probably. So don't worry about that. Not open it yet. Okay, I'm going to give a few seconds. So where are you? Are you waiting for the simulation to load, or are you opening the project? Are you getting any error here in the simulation command, or what is your current state? Hello, Audacious. Hello from Barcelona. Okay, yes, Spirit, that's right. That's all right. That's the expected output, as you can see. Have you clicked here in the gazebo icon in order to open this window? Remember, you need to click here in the gazebo icon, in this one here. You need to click here so that this window gets opened. You can also try to refresh, to click here on the refresh button. In case for some reason maybe it gets stuck or whatever, you can click here on the refresh button, and maybe this way it's going to refresh everything and you will see it better. So you can also try that. Florencia says, I added like 4 shapes and can't see the robot. Control plus right click doesn't delete them. Yeah, it depends on the configuration. So for instance, I'm adding here a circle. Yeah, I think this might be an issue, a strange issue, because it's not easily, we cannot delete things easily, and we should. So I'm going to take note about this so that we have a look at it. In any case, Florencia, if you cannot do it, just stop the program here where you are launching the simulation. You can stop it here by pressing Ctrl-C, and this is going to stop the simulation. So you press Ctrl-C here in the command, and then you can come back here and execute the command again, okay? So you stop it with Ctrl-C by pressing Ctrl-C, and then you launch the command again. And this is going to reload the simulation from the beginning again, you see? And it's going to be everything, it's going to start from zero. So you can do this. Stop, you come here, press Ctrl-C, and it's going to stop the simulation, and then you launch it again, okay? Then let me have a last look here at the chat. For starting ROS, why you did not use ROS core? Because ROS core is automatically launched with the ROS launch command here. That's why. How long, here, a very good question, says Gotham, how long it will take to become good at ROS? Well, it depends. It depends at what does it mean to be good at ROS for you. So in order to get it depends on many things. It depends on which is your background, if you have already some background in programming or not. It depends in how many time you are willing to spend in order to learn. It depends on many things. I can tell you that it's not easy, so it requires some work to learn ROS. But yeah, I would suggest you, if you want to start learning ROS, to have a look at our ROS Basics in 5 days course in Python. I suggest you have a look at that course, and I think that's the fastest way you can have a good basis, a good base in ROS. Let me see some comments here. It works. It will, okay, I can see you are starting answering between yourself. What is the difference between using ROS Launch and ROS Core? Well, ROS Core is just going to start the core of ROS, let's say. It's just going to start the main, it's going to start a main node where you are going to be able to start launching things from there. With ROS Launch, you are automatically starting ROS Core, but you are also launching some ROS programs already. So basically that's the difference. ROS Core, it's inside, let's say, ROS Launch. Ready, everything is loaded. Okay, let's see going. So I can see that we have a lot of people here in the chat today, but we need to keep going because otherwise we are not going to be able to do today's live class. So let's go for it. Let's go for it. Okay, I'm going to try to complete as much as I can because we have already spent a lot of time here in the setup. But since I have seen that today we had many new people, I wanted to spend a little bit more time here in the setup. Okay, so let's start. Then, first of all, variables and addresses. So, when in our program we declare a variable, it immediately gets stored in the computer's memory. So this is important. When we declare a variable in C++, it immediately gets stored in the memory of the computer. Then in C++, we first declare the variable and later we assign it a value. So from the very beginning, this variable gets assigned a location in the computer's memory. We call this location in the memory an address. So if we need to access this variable, for example, print its value, we don't need to know the memory address. We only need to know its identifier, also called name. For example, here we are initializing a variable, name my variable, and we are declaring this variable, which is of the type integer, and we are giving it a value of 42. Then this variable is going to immediately get stored in the memory with a unique address. Then you can think of the memory as a huge amount of small cells, one of which contains the value of our variable, this one in this case, an address to find it, and the name to get its value. So we can see this image that we have here. Let me make this bigger in order to better understand this. We can think of the memory as lots of cells like these ones. Then we can see here that each of the cells is going to have an address. This address is it's a space in the memory which corresponds to this variable. So in this case, let's focus on this one, which is our variable, the one that we have declared. So we have declared here my variable. We can print it, for instance, and it's going to show a 42 number. Then this cell here is going to be our variable. In this case, this cell is the place in the memory where our variable is stored. Then this cell has an address, which is this number here, 177687. This is the address of where our variable is stored in the memory. Then this variable also has a name, which in this case it's my variable. And finally, it also has a value. It contains a value, which in this case it's 42. It's the value we have assigned to our variable. Yes, does it make sense? Then, so as you can see here, we can access the address of the variable by using the operator AND. So here, if we use the operator AND and the name of our variable, we can see the address, which is basically the location in the memory. Let's say the cell in which our variable is stored, the cell in the memory. Yes, so we can access the address by using the AND operator. Okay, then this would be a basic definition of a variable in C++, let's say. Then what about arrays? Well, an array is a series of elements of the same time placed in contiguous memory locations. So here we are only using one memory location, one memory address, right? Then an array is basically a series of elements of the same time placed in contiguous memory locations. We can see this better. I don't know if we have an image here. No. But let's imagine here we have all these cells occupied by different integer numbers. Then that could be an array. So for instance, to initialize an array, we have to specify which type are the variables inside it and how long the sequence is going to be. For example, for an array of integer values with 6 numbers, we would declare it like this. Integer, the name of the array, and in this case we are initializing it to 6 positions. We can also assign directly values, and in case we are automatically assigning values, so we are initializing all the positions of the array, we don't have to specify here the size of the array. It's not mandatory, let's say, in case we initialize it. If we don't initialize it, like here, it's mandatory to specify here the size of our array. Yes? Then all the elements of an array can be accessed using the same identifier or name. The name is going to point to the first element of the array, and using indexes we can access the others. So in this case we are accessing the my array and the index number 2. So what is this going to print? It's going to print 15. And why 15 and not 8? Because 8 is the second number. Can somebody answer to this question? If I'm accessing here the index position 2 of my array, and in my array the second number has an 8, why this is not printing me the 8, but it's printing the 15? Can somebody answer to this question? In the chat? Come on, guys. I'm sure someone knows the answer. Yeah, that's it. Because arrays start with 0. That's it. Very well, Micho and Engineering Nations as well. So the number 4, it's the first position. It's the first number that we have in the array, but this is the 0 position actually. In an array, this is the 0 position. So when we index an array, the first position is going to be the index 0. Yes, so that's why. Then if we access the index number 2, we are going to have 0 position, 1 position, 2 position. So I'm going to get the number 15. Yeah, makes sense? Then we can also print all the elements of an array with a for loop. So we can create a for loop here in order to iterate over all the items of an array, etc. Then, okay, let me check here. I think this doesn't have the last version. Yeah, this doesn't have, okay. Okay. Yeah, for some reason, this is not the last version of the notebook. I don't know exactly why. But, well, it doesn't matter. We can keep going. No worries. Then, okay. Then let's do an exercise. Let's do a quick exercise. So here we have the robot, and as we have just seen, well, as I have showed you before, here in the robot, we have a laser mounted. You can see it here, this cylindrical element that we have here in black. This is a laser. And in this case, this laser covers a range of 360 degrees, as we can see in this image here. So this is a graphical, simplified representation of all the laser beams. And it starts with the 0 position here, and the 719 position here. So this might seem a little bit confusing right now. So let's try to see it better. So the laser covers the 360 degrees around the robot. So you can see here. And returns an array of distances of where the obstacles are. So we are going to use a class, in this case, function called getLaser, to obtain a single reading of the laser in the orientation you desire. As you can see on the picture above, if you pass as a parameter to the function the value 0, you will obtain the reading from the front. So here we have an indication. So in the laser beam which we have in the front of the robot, which is pointing in this direction, we can get this laser reading by accessing the index number 0 of the laser array. Then this is going to keep going to the right side, so in a clockwise direction. Here we have the index position 180, 760, which is basically the back side of the robot, the rear side of the robot, and then it keeps going, and finally it's going to end up here with the 719 position. Yeah, makes sense. So following a clockwise rotation, we start from the 0 index and we end up here at the index number 719. Then, yeah, so the value 360 will obtain the reading from the back, and the value 719 in this case will obtain the reading from the front, but a little to the left. So summarizing, what we want to do here is to, first we are going to ask the robot to move forward as many seconds as we want. Then we are going to call the getLaserN function. Actually, let me see one thing, because this. Okay. No. Okay. No worries. All right. Yeah. So after I finish the live class, I'm going to update this project, because this is not the one I prepared, it's another one. So once this live class finishes, I'm going to update this project. So once I do that, you are going to be able to get the updated version by coming here. Let me just explain this very quick. You are going to be able to update the version of the project by coming here, and here you are going to see a symbol. It's going to appear here, a symbol, which is going to allow you to update the project to the latest version. Okay, but yeah, for now I'm going to just keep going. All right, then okay, yeah, so here we have an example script. So let me very quickly come here and see what I have here. Scripts, okay, this is all empty, great. Actually, yeah, definitely it's this one. Let me see one thing. No, it's not the last version. Okay, well, let's keep going. All right, then what we are going to do, so if you come here to the code editor, you're going to see that inside the Catkin workspace, you have here a folder which is named CPP Live Class. Yes? You can come also here through the, let me minimize this one. You can come here also through the shell, cd Catkin workspace src, and here you're going to see that we have this CPP Live Class folder. But I prefer to manage all this from the graphical here tool, from the IDE. Then here you have the CPP Live Class. And inside here you're going to see that you have a folder which is named C_scripts. Then inside here we have also a folder which is named src. Then here inside this src folder I'm going to create a new file which I'm going to name laserreadings.cpp. Okay? Then of course this file is going to be created empty. So what I'm going to do now is to come here to the notebook and copy this script, laserreading.cpp. I'm going to copy it from here, from the notebook. I'm going to copy the code and paste it here into my file here. Yes? Then let's quickly analyze what is going on here. So basically here we can see some basic C++ code. So we are doing an include here of the ROSbot class. This ROSbot class basically it's a class that provides a middleware, let's say, between C++ and ROS. So basically this ROSbot class contains all the ROS code in order to be able to interact with the robot. Why it contains all that? Because in this case, in this course, which is the one which is based this live class, in the course of C++, let me show it to you. Here, in this class, we want to focus on teaching C++, not ROS. So that's why we have kind of hidden all the ROS code. Because we want you to focus on learning C++, how to program in C++, and C++ concepts. So that's why we have created a class, which is this ROSbot class. In fact, you can have a look at this class here. Basically, this class contains all the ROS things. You can see here subscribers, publishers, whatever. But all this, we want to keep it hidden in this case and focus only on the C++ code. Then, what we are doing here, basically we are creating a main function. Then we are initiating a ROS node here. This is the only ROS code that we have added here. And then what we are doing is to call this move forward function. This function, what it's going to do is to make the robot move forward during 3 seconds. Yes, this move forward function, in fact, is a function which is declared here. We can look for it here. Move. You can see it here, move forward. Yes? Then we are calling this function in order to move the robot forward during 3 seconds. Then we are calling the getLaser function. This function is going to return us the value of the laser depending on the number we send as a parameter. So for instance here, we are calling this function with the number 121, and here we are calling the function again with the number 431. So for the number 121, this number is going to be more or less around, somewhere around here, right? Somewhere around here. And the number 431 is going to be somewhere around here, in fact. Yeah, 360, we have it here, so 431 is going to be somewhere around here. So, here we are getting the readings, 121 and 431. Then, here we are declaring an array, which is named ArrayLaser, which is going to contain these values, the value right and the value left. Then finally, what I'm doing here is to do a print, basically, and I'm going to print the value in the index 0 from my array and the value in the index 1 from my array. Yes, makes sense, more or less. So it's pretty basic. And basically this program is just to test what we have been seeing here with all these examples on the arrays, etc. Then let's compile it. Let's just straightforward. Let's go and compile it. Let me see if this is ready to be compiled. Reading / final. It's ready actually. So what I'm going to do right now is to come here, come to the Capkin workspace folder, and compile this. Okay, yes, so actually we are getting an error here, and it's because of this, because this is not the last version of the project. I don't know why, honestly, but yeah, so in order to solve this, all we have to do is we can create a new file here and name it laser full cpp. We can leave it empty, and now let's just here source opt set a bash, important to source always, and Catkin make. This is still complaining. Okay, actually, let me not make it like this. There. Actually, the best thing we can do right now is to remove here from the CMakeList file. We can see that here we have the compilation data in order to compile this laser reading CPP. So what I'm going to do here is to remove this last line, which is the laser final. Just remove it from here. And now it will compile. Now we can properly execute Catkin make. So now we should just source here, source devel setup bash. All right, and yeah, so now we can test it. We can run it. So we can run it by using, so here we have kacking workspace, kacking make, we source, and then we can run it here with the following command. So Chris, let me focus here on the simulation so that I can see what's going on. Then let me run it. We are going to see the robot start moving forward for 3 seconds, and then it's going to stop, and it's going to print here the readings it got. So the wall is at inf meters to the left and 1 meters to the right from the robot. Yes, so the right value, which is this one, let's go back to the code. The right value, we have it here, it's getting the position 121, which if we have a look at the image in the notebook, we can see that it's somewhere around here. So this value, it's returning me 1.89 meters, because this is detecting probably this side of the wall. On the other hand, in the left, I'm getting the inf value. Why? Because here I'm checking the value of the array in the index 431, which more or less it's pointing to this direction. And the robot, in this direction here, it doesn't have any obstacle, right? In this direction here, the robot doesn't have any obstacle. So it's not detecting any obstacle, and it's returning an inf value. So in fact, if we actually want to get the left side reading, can somebody tell me more or less which value should I use here instead of 431? Which value more or less should I use so that I get the left side of the wall, more or less? Can somebody tell me? More or less. It doesn't have to be accurate, but more or less. Which number should I use? 718. Yeah, that's an option. 719, though, it's going to return more or less the front side. More or less. It's going to be pointing here to the front a little bit to the left. So we can even move it a little bit more to the left by, let's say, getting, I don't know, 690 maybe, or 680, something like that. So let's try it. Let me do one thing. I'm going to reset here the robot position. Reset the world. There we go. Then let me try, for instance, I don't know, 600. No, sorry, not this one, but this one. 680, for instance. Let me try this one. So I'm going to recompile. Very important. I need to recompile because I'm working with C++, which is a compiled language. So let me try to run it one more time and see what I get now. So let me put this here and get a bit closer. And rerun here my program. It moves forward for 3 seconds. There you go. Okay, so now I'm getting inf to the right. I'm getting a good value to the left, but to the right, it's getting an infinite meters to the right. Okay, so now I'm getting infinite to the right. So this means that it's too on the edge, this value. So I should lower it a little bit. Probably if I get if I put a 100, it's going to be more accurate and it's not going to fail. So we can try this. Let me put this again here. cut in make. You can keep playing with the values in any case and see how it affects, whatever. Let me run it now. And now I should get both values. Yeah, so now I'm getting the left value 1.3 and right value 1.97. So more or less. Yes, we can keep changing this, whatever. In any case, okay, so yeah, here we have an example of how to use an array. For instance, in robotics, this is very useful to store laser readings. We can also store other things, but in many cases, you are going to need to use arrays in order to store laser data. That's a very common case. In order to store this data and analyze it, in order to, for instance, detect obstacles or any other case. But this is super useful for this. Then we have many more things to keep doing here, especially to talk with pointers. But we are already on time, so we are not going to have time for this. So maybe I'm thinking of completing this live class on next Tuesday, maybe. What do you think? So that we can have a look at pointers. I don't know. In any case, we've had some problems today, which made us, which took us a lot of time at the beginning, especially. Also, no, I can see that this notebook is not the final version I prepared, actually. So yeah, I don't know. I'm going to think about it. Maybe we can finish this live class next week, or if not, I'm just going to update the notebook, and you can finish by yourself the notebook. Since you are going to have we are going to have this project in your workspace forever. So if you come here to your account and your project, you are going to have this one forever. So you can open it. You can keep working now after we finish the live class. You can open it tomorrow, have a look, keep looking at it. As I have said before, I'm going to update it so that you can get the latest version of the notebook. And yeah, so yeah, if I wanted, I would have liked it to do everything I have planned here with pointers, which is super interesting, but we have no more time, sadly. So yeah, I will see what I do. I will see if we finish it in next Tuesday, or if we just keep doing other things and I leave it for you to finish it by your own. I don't know. We'll see. Okay, let me check here. Okay, we have more answers here. 710. Yeah, that's right. Which file did he edit and deleted the last 4 lines in order to get the build running? CMake lists. Yes, that's right. Misho, it's cmakelist.txt. I edited this one. And I removed these last 4 lines. So that you only have laser readings here. Sure, yes, agreed. It would be good to look at pointers next time. What do you think? Let's do it next Tuesday, okay? The notebook is very clear, thank you. I work on it on my own too. Yeah, it has too much information, Florencia. So I was summarizing everything and changing some instructions so that we don't have this kind of errors. But for some reason, it didn't get saved, the last version. I don't know why. My bad. In any case, it's my bad. It's fine. Thanks for the class. Can you paste a email list that is correct, please? Yes, it's this one. So the original one, the one that comes with the ROSjet, it has something down here. It has 2 sections like this. This one, it says laser full. Yes? So all you have to do is to get this one, these last 4 lines, and remove them. That's it. If you do this, it's going to compile. Great, thanks. Is there a cheaper subscription option for students? I don't think so currently. So currently, I think we have only the weekly. I think we have the monthly subscription, which is I will need to check it. In fact, but no, currently we don't have a cheaper subscription for students for NCR. In any case, if you would like to have more information on that, I suggest you send an email or or follow us in our social medias, because sometimes we publish some offers or things like that, so that you can get some of them. So I would suggest you that. Okay, so yeah, thank you very much. Sorry for the issues we've had today. So I'd love to subscribe for access to all courses, but it's expensive for me right now. Why do you compile only when you delete those 4 lines? Joy, right? Well, because if you leave these lines, it's expecting here to have another program, which we don't have right now. We were supposed to do it later. We were supposed to do another program and compile it. But right now we have only created this one, so we have to remove this and compile only these ones. Otherwise, if you leave the other one, it's expecting you to have another program here, which we don't have right now. That's why. Super quickly. Okay, so already 10 minutes past the time. Let's cut it here. As I was saying, sorry for these errors we had during today's session, so we couldn't finish it in time. So probably we're going to finish it next Tuesday. So stay tuned. Thank you very much for the ones who have been here with me. Let me change right now the camera. There I am. So thank you very much. I will see you next Tuesday in next live class. Until then, take care and keep pushing your ROS learning. Bye-bye.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises. A fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.